Hey all, this is Kalpana here. In this video we are going to solve a differential equation. So we are given a differential equation x into 4ydx plus 2xdy plus y cube into 3ydx plus 5xdy equal to 0. Right? Here you are having x. We can write this x as x into 1. Write x as x power 1 and this 1 as y power 0, since y power 0 equal to 1. So that you'll have two variables here, x and y. So we can write x as x power 1 into y power 0 into the terms under brackets, plus here you're having y cube, right? Y cube as 1 into y cube. Just replace this 1 by x power 0, since x power 0 equal to 1, so that you'll have two variables here, x and y, right? So just write y cube as x power 0 into y cube into terms under brackets. So this equation is of the form x power a y power b into mydx plus nxdy plus x power c y power d into pydx plus qxdy equal to 0. Since the given differential equation can be written in this form, so here x power alpha and y power beta will be our integrating factor. Also, we can write the given differential equation in mdx plus ndy equal to 0 form, and here we are going to get non-exact. Okay, now coming to the problem. Given differential equation, x times 4ydx plus 2xdy plus y cube into 3ydx plus 5xdy equal to 0 considered as equation number 1. Also, we can write this equation as 4xy dx plus 2x squared dy plus 3y power 4 dx plus 5xy cube dy equal to 0. Now write the terms involving dx firstly and then dy. So I'll begin with dx now. 4x dx plus 3y power 4 dx plus, now write the terms involving dy. Right? Now take dx common from the first two terms. You'll get 4xy plus 3y power 4 into dx plus 2x square plus 5xy power y cube into dy equal to 0, right? Which is of mdx plus ndy equal to 0 form. Where m equal to 4xy plus 3y power 4 and n equal to 2x square plus 5xy cube. If partial derivative of m with respect to y equal to partial derivative of n with respect to x, then we can say that the given differential equation is exact. So let's find the partial derivatives of m and n. We have m 4xy plus 3y power 4. Since it is partial derivative with respect to y, so x is treated as constant. You'll get 4x into dou by dou y of y plus 3 constant 3 into dou by dou y of y power 4, which gives us 4x into partial derivative of y with respect to y is 1 plus 3 into partial derivative of y power 4 with respect to y is 4y cube. We'll get 4x plus 3 4s are 12 y cube. So this is the result obtained for partial derivative of m with respect to y. Let's now find partial derivative of n with respect to x. This is equals to dou by dou x of n 2x square plus 5xy cube, right? Since we are finding partial derivative with respect to x here, so y is treated as constant, so you'll get, or you can write the above expression as partial derivative of x square with respect to x plus 5y cube constant into partial derivative of x with respect to x. This gives us 2 into partial derivative of x square with respect to x is 2x plus 5y cube into partial derivative of x with respect to x is 1, which gives us 2 2s are 4x plus 5y cube. By observing these two, we can say that partial derivative of m with respect to y is not equals to partial derivative of n with respect to x. So this shows that 1 is not exact, right? The given differential equation is not exact. Now coming to equation 1. As we discussed earlier, we can write x as x power 1 into y power 0 into 4ydx plus 2xdy plus y cube can be written as x power 0 into y cube into 3ydx plus 5xdy equal to 0, right? Which is of the form x power a y power b into mydx plus nxdy plus x power c y power d into pydx plus qxdy equal to 0, right? Where a equal to 1, b equal to 0, c equal to 0, d equal to 3. Just by comparing these two equations, we'll get the values of constants. M equal to 4, n equal to 2, p equal to 3, and q equal to 5. Since the given differential equation is of this form, so here x power alpha and y power beta will be the integrating factor. Let x power alpha, y power beta be the integrating factor of 1. Now, multiplying 1 by integrating factor x power alpha, y power beta, we'll get x power alpha, y power beta into the given differential equation or we can write this as x power alpha, y power beta into 4xy dx plus 2x square dy plus 3y power 4 dx plus 5xy cube dy equal to 0, or x power alpha, y power beta into 4xy dx plus 2x square dy plus x power alpha, y power beta into 3y power 4 dx plus 5xy cube dy equal to 0, right? Or we'll get 4 x power alpha x into y power beta y into dx plus 2 x power alpha x square into y power beta into dy plus 3 x power alpha y power beta into y power 4 into dx plus 5 x power alpha into x, y power beta into y cube into dy equal to 0, right? Or we can write this as 4 into x power alpha into x can be written as x power alpha plus 1 into y power beta into y power 1 can be written as y power beta plus 1 into dx plus 2 x power alpha into x square can be written as x power alpha plus 2 and y power beta dy plus 3 x power alpha into y power beta into y power 4 can be written as y power beta plus 4 into dx plus 5 x power alpha into x can be written as x power alpha plus 1 into y power beta into y power beta cube can be written as y power beta plus 3 into dy equal to 0. Now take dx common from the first term and the third term and take dy common from the second term and the last term. We'll get 4x power alpha plus 1 y power beta plus 1 plus 3x power alpha y power beta plus 4 into dx plus take dy common from these two terms, we'll get 2 x power alpha plus 2 y power beta plus 5 x power alpha plus 1 into y power beta plus 3 into dy equal to 0. Consider this equation as equation asterisk. Okay. So here asterisk is exact if partial derivative, see this equation is of the form mdx plus ndy equal to 0, right? So we can say that this equation is exact if partial derivative of this term with respect to y equal to partial derivative of this term with respect to x, right? Right, we'll get it is partial derivative with respect to y, so x is treated as constant in the first term, 4 x power alpha plus 1 is constant in the second term, 3 x power alpha is constant, so we'll get 4 x power alpha plus 1 into partial derivative of y power beta plus 1 plus 3 x power alpha into partial derivative of y power beta plus 4 equal to, in the RHS we need to find partial derivative with respect to x, so here y is treated as constant in the first term, 2 y power beta is constant and in the second term 5 y power beta plus 3 is constant, right? So we can write this as 2 y power beta into partial derivative of x power alpha plus 2 with respect to x plus 5 y power beta plus 3 into partial derivative of x power alpha plus 1 with respect to x, right? This gives us 4 x power alpha plus 1 into partial derivative of y power beta plus 1 with respect to y is beta plus 1 into y power beta plus 1 minus 1 plus 3x power alpha into partial derivative of y power beta plus 4 with respect to y is beta plus 4 into y power beta plus 4 minus 1. This equals to 2 y power beta into partial derivative of x power alpha plus 2 with respect to x is alpha plus 2 into x power alpha plus 2 minus 1 plus 5 y power beta plus 3 into partial derivative of x power alpha plus 1 with respect to x is alpha plus 1 into x power alpha plus 1 minus 1, right? This gives us 4x power alpha plus 1 into beta plus 1 into y power plus 1 minus 1 gets cancelled, you will get y power beta plus 3x power alpha into beta plus 4 into y power beta plus 4 minus 1 is plus 3 equal to 2y power beta into alpha plus 2 into x power alpha plus 2 minus 1 is plus 1 plus 5 y power beta plus 3 into alpha plus 1 into x power plus 1 minus 1 gets cancelled and you'll get alpha, right? Again we can write this as 4 beta plus 1 into x power alpha plus 1 y power beta plus 3 beta plus 4 into x power alpha y power beta plus 3 equal to 2 alpha plus 2 into x power alpha plus 1 y power beta plus 5 alpha plus 1 into x power alpha y power beta plus 3, right? Now we can equate the quotient of x power alpha plus 1 y power beta and equate the quotient of x power alpha and y power beta plus 3. Okay, equating the quotients of x power alpha plus 1 y power beta, which gives 4 times beta plus 1 equal to 2 times alpha plus 2, or you can write this as, just bring this to LHS, you'll get 4 by 2 into beta plus 1 equals to alpha plus 2, which gives us 2 times beta plus 1 equal to alpha plus 2, or 2 beta plus 2 equal to alpha plus 2, right? Which gives us 2 beta, or you can write this as alpha plus 2 equal to 2 beta plus 2. Now bring these two terms to LHS, you'll get alpha minus 2 beta plus 2 minus 2 equal to 0. From this we'll get alpha minus 2 beta equal to 0, right? Now equating the equations of x power alpha y power beta plus 3. Which gives us plus 3 times beta plus 4 equal to 5 times alpha plus 1. We'll get 3 beta plus 12 equal to 5 alpha plus 5, or we can write this as 5 alpha plus 5 equal to 3 beta plus 12. Now bring these two terms to LHS, then we'll get 5 alpha minus 3 beta plus 5 minus 12 equal to 0, which gives us 5 alpha minus 3 beta plus 5 minus 12 is minus 7 equal to 0, right? Consider this equation as equation number A and this equation as equation number B. Now by solving A and B, we'll get alpha and beta values. See, here we are having equation B, 5 alpha minus 3 beta minus 7 equal to 0, or we can write this as 5 alpha minus 3 beta equal to 7, right? Let's now solve equation A and equation B. See, in order to cancel the terms involving alpha, we need a 5 here, right? Let's multiply 5 to equation A, then we'll get 5 alpha solving A and B. 5 alpha minus 5 to the 10 beta equal to 0. Equation B, just write it as it is. Now change the signs. You can cancel plus 5 alpha and minus 5 alpha. You'll get minus 10 beta plus 3 beta, which is minus 7 beta, equal to minus 7. From this we'll get beta equal to minus 7 by minus 7, which is 1. Therefore beta equal to 1. Now substitute this beta equal to 1 in equation A. Substitute beta equal to 1 in A. We have equation A, alpha minus 2 beta equal to 0. Now substitute all beta values since beta equal to 1. So you'll get alpha minus 2 into 1 equal to 0. From this you'll get alpha minus 2 equals to 0, which gives us alpha equal to 2. Therefore alpha equal to 2. Right? Therefore alpha equal to 2 and beta equal to 1. We have alpha equal to 2, beta equal to 1, right? Then the integrating factor becomes x power alpha y power beta equal to x power 2 y power 1, right? Or x square into y. Therefore x square into y is the integrating factor to our problem. Now multiplying 1 by integrating factor x square into y gives x square into y into the given equation, x times 4ydx plus 2xdy plus y cube into 3ydx plus 5xdy equal to 0. We can write this as x square y into 4xy dx plus 2x square dy plus 3y power 4 dx plus 5x y cube dy equal to 0. Now multiply the integrating factor, you'll get 4. X square into x is x cube, y into y square dx plus 2 x square into x square x power 4 into y dy plus 3 x square y power 4 into y is y power 5 dx plus 5 x square into x is x cube, y into y cube is y power 4 into dy equal to 0, right? Now take dx common from these two terms. We'll get 4x cube y square plus 3x square y power 5 into dx plus, now take dy common from these two terms. We'll get 2x power 4y plus 5x cube y power 4 into dy equal to 0. Right? Consider as equation number 2, which is of the form, here also this is in Mdx+Ndy form, which is of the form say m1 dx plus n1 dy equal to 0, where m1 equal to 4x cube y square plus 3x square y power 5 and n1 equal to 2x power 4y plus 5x cube y power 4. If the partial derivative of m1 with respect to y equal to partial derivative of n1 with respect to x, then we can say that the reduced equation, equation 2, is exact. Partial derivative of m1 with respect to y. We have m1 4x cube y square plus 3x square y power 5. So here we are finding partial derivative with respect to y, so x is treated as constant. In the first term 4x cube is constant, in the second term 3x square is constant, right? So we can write this as 4x cube into partial derivative of y square with respect to y plus constant into partial derivative of y power 5 with respect to y, right? This gives us 4x cube into partial derivative of y square with respect to y is 2y plus 3x square into partial derivative of y power 5 with respect to y is 5y power 4, which gives us 4 2s are 8 x cube y plus 3 5s are 15 x square y power 4. Therefore, partial derivative of m1 with respect to y equal to 8x cube y plus 15x square y power 4. Let's now find partial derivative of n1 with respect to x. Dou by dou x of n1 2x power 4y plus 5x cube y power 4, which gives us, here it is partial derivative, we need to find partial derivative with respect to x. So here y is treated as constant. In the first term 2y is constant, in the second term 5 y power 4 is constant. You'll get, or you can write the above expression as 2y into partial derivative of x power 4 with respect to x plus 5y power 4 into partial derivative of x cube with respect to x. This gives us 2y into partial derivative of x power 4 with respect to x is 4x cube plus 5y power 4 into partial derivative of x cube with respect to x is 3x square, which gives us 2 4s are 8 x cube y plus 5 3s are 15 x square y power 4. Therefore, partial derivative of n1 with respect to x is 8x cube y plus 15x square y power 4, right? So by observing these two, we can say that partial derivative of m1 with respect to y equal to partial derivative of n1 with respect to x equal to 8x cube y plus 15x square y power 4, which is nothing but equation 2 is exact. Therefore, equation 2 is exact. Now let's solve equation 2 to find the general solution to our problem. The general solution to equation 2 is given by integral m1 dx treating y as constant plus integral terms of n1 free from x into dy equal to c. Okay, let's now find integrals separately, or evaluate integrals separately. I'll begin with integral m1 dx treating y as constant. This is equals to integral m1 4x cube y square plus 3x square y power 5 into dx. Since here y is treated as constant in the first term, y square is constant, 4 is constant in the second term, 3 and y power 5 is constant. So we can write this as 4y square integral x cube dx plus 3y power 5 into integral x square dx, which gives us 4y square into integral x cube dx is x power 4 by 4 plus 3y power 5 into integral x square dx is x cube by 3. 4 gets cancelled and 3 gets cancelled. This gives us x power 4 y square plus x cube y power 5. So the result obtained from the first integral is x power 4 y square plus x cube y power 5. Now coming to the second integral. Integral terms of n1 free from x into dy. So observe n1, we are having 2x power 4 y plus 5x cube y power 4. Do we have terms which are free from x here? We don't have any terms which are free from x because both the terms involves x, right? So this is equals to 0. So the result obtained from the second integral is 0 because we don't have any terms of n1 which are free from x. So the second integral is 0. Now coming to the solution to equation 2. Result obtained from the first integral is x power 4 y square plus x cube y power 5 plus result obtained from the second integral is 0 equal to c, which gives us x power 4 y square plus x cube y power 5 equal to c, which is the required solution. Or take x cube common from these two terms and y square common from these two terms, right? Or x cube y square common simply. Then you'll get x plus y cube equal to c, that is x cube y square of x plus y cube. See, x cube y square into x gives x power 4 y square plus x cube y square into y cube gives x cube y power 5. Therefore, x power 4 y square plus x cube y power 5 equal to c, or x cube y square of x plus y cube equal to c is the required solution to our problem. Okay. So we have seen a problem from differential equation in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.